Good day, everyone. So, we are the Group 2, and the topic that we're going to discuss to you is all about the heat engines. So, nowadays, vehicles are widely used means of transports to move from one place to another. Nowadays, every family can possess at least two wheelers. Just imagine how the vehicles are moving. What is the energy used in it? What is the process that has undergone? A heat engine is the only answer to all those questions. So, what is this heat engine? So, a heat engine is a device used to convert a heat energy into a mechanical work rather, which is useful for people. It uses a simple apparatus to perform the procedure. The heat engine possesses several advantages along with few limitations. So heat engine is only heat energy that converts into mechanical work. Now let us consider a device that uses heat transfer to do work. As noted, such a device is called a heat engine. Gasoline and diesel engines, jet engines, and steam turbines are all heat engines that do work by using part of the heat transfer from one some sources. Heat transfer from the hot object or hot reservoir is denoted as QH, while heat transfer into the cold object or cold reservoir is QC. So we could already seen this in our image, and the work done by the engine is the W or the work. The temperature of the hot and cold reservoirs are TH and TC respectively. So the hot reservoir is heated externally, which is energy intensive. It is important that the work is done as efficiently as possible. In fact, we would like W to equal QH and for there to be no heat transfer to the environment, or the QC equals to zero. Unfortunately, this is impossible. The second law of thermodynamics also states with regard to using heat transfer to do work. So here are the classification of heat engine. We have five different types of heat engines. There are two types well-known and widely used heat engines. Among the five, the characterization has taken place based on the principle which is used to convert heat energy into mechanical work. So the types of heat engines are as follows. First is the internal combustion engine. Second is the Stirling engine. Third is the diesel engine. Fourth is the steam engine. And fifth is the reciprocally steam engine.
What is the function of the heat engine? The primary function of any heat engine is to convert the available heat energy into useful mechanical work. It undergoes various procedures to convert the same. It moves energy from a hot place to a cold place and diverts some of that energy into mechanical energy. So the main objectives of the heat engine is to supply process heat demand and to generate power. Efficiency of the heat engine. Generally, we know that efficiency is capability. However, here the efficiency of a heat engine is the difference between the hot source and sink. That is the difference between the heat reservoir and the cold reservoir. It can also be termed as the thermal efficiency of the heat engine. The maximum efficiency of a heat engine is the highest difference between hot and cold reservoirs. Kelvin is the measuring unit for this efficiency. So, efficiency of heat engine relates to how much useful work is output for a given amount of heat energy input. The thermal efficiency may vary from one heat engine to another heat engine. To understand more about this, let's take the reliable heat engines and their efficiencies. The efficiencies of various heat engines are as follows. It is just 3% efficiency for ocean thermal energy conservation. Automotive gasoline engines are nearly 25% efficient. Similarly, coal-fired power stations have 49% efficiency, and it is around 60% efficient for the combined cycle gas turbine. The efficiency of the heat engine formula. As the efficiency of the heat engine is a fraction of heat and the obtained useful work, it can be expressed using a formula and a symbol. The efficiency of heat energy formula is eta equals W divided by QH. So W is the thermal work, useful work obtained. QH is the given amount of energy and eta N is the thermal efficiency. So this is known as the heat engine formula. According to the second law of thermodynamics, it is impossible to get 100% of the thermal efficiency. It always ranges between 30 to 60% of thermal efficiency because of the environmental changes and other factors. We can also consider the work attained is the difference between the initially sent amount of heat and the obtained heat. It can be expressed as eta equals initial heat obtained minus obtained heat divided by initial sent amount of heat. So the heat engine concept was first introduced and discovered by a French physicist, Nicolas Leonard Sadi Carnot in 1824. The Carnot engine is the ideal heat engine. As it is the most efficient heat engine, its efficiency is initial sent amount of heat divided by obtained heat minus obtained heat divided by initial sent amount of heat. It can be measured for every Carnot cycle.
Now let's move on to the PV diagram, which is the pressure volume diagram, which helps to study and analyze the efficiency of a heat engine. It acts as a visualization tool for the heat engine, as we know that the working substance may be any gas. The PV diagram explains the visuals from the heat engine by considering the ideal gas law. Even though the temperature may vary continuously, the PV diagram helps to explain the three elements in the state of the variables. It is also used for the first law of thermodynamics to explain the variation in heat engines. So if we observe the figure, so atong matanaw diri is ang pressure of volume. This is the PV diagram. So we can understand that the PV diagram is a single cyclic heat engine process. It appears as a closed loop. The area inside the loop represents the amount of work we have done in the process and the amount of useful work we obtain. The pressure volume diagram is beneficial and an advantageous visualization tool to study and analyze the heat engine. So, ato makita dira is ang na diri ang heat added. So, gray siya. Tapos work done niya by gas. So, mo to reduce. Tapos ang volume pod reduce po na siya. Tapos heat extracted, paubos na sad and pabalik na sad dayon sa pressure. So, it's a cyclic ano. Oop, ano ba? So let's do a sample problem. So this is the problem. The coal-fired powered station is a huge heat engine. It uses heat transfer from burning coal to do work to turn turbines which are used to generate electricity. In a single day, a large coal power station has 2.5 times 10 to the power of 14 joules of heat transfer from the coal and 1.48 times 10 to the power of 14 joules of heat transfer to the environment. So, like, ilang gaingon ganina, dili jud siya 100% ang heat, kay nadyo ma-transfer sa environment. So, ato ang problem is, what is the work done in the efficiency and sample problem 1C nato is the gilahi na po ang iyang kuan. The following chemical reaction occurs at C plus O2, which is yield to carbon dioxide. This implies that every 12 kilogram of coal puts 12 kilogram plus 16 kilogram. 16 kilogram equals 14 kilogram kay CO2 man. C is 12, O is 16. So, duha man sila. So, 16 plus 16, then plus 12, then 44 siya. So, assuming that 1 kilogram of coal can provide 2.5 times 10 to the power of 6 joules of heat transfer upon combustion, how much CO2 is emitted per day? So, atong problem is, gilahi na ito ang kuan transfer, which is the 2.5 times 10 to the power of 16. So, atong isolve. So una ang atong ipangita is ang work done, sunod is ang efficiency, ang ikatulo is katong gilahi ang iyang ano. So work done sa tauna, so ang work done is W equals QH minus QC, or dito sa among gigamit ganina is W equals Q1 or minus Q2. So QH QC siya pwede ra pod, Q1 Q2 pwede ra pod. So atong QH is 2 point nara atong given and QC po nato. So atong i-substitute tapos makita din nato dire gi-minus siya. So ato ang result is 1.02 times 10 to the power of 14 joules. So next nakuha na nato ang work done nato. So next is the efficiency na pod. So ang efficiency dito gipakita ganina is katong N, katong mura siyang N nga naitaas nga TL tapos minus Q1 QC divided by Q1. So atong gigamit man diri is QH minus QC tapos mura man na siya, work done man siya, di ba? So ato na lang siyang gidiretso. So W divided by QH na to diretso or Q1. So tara din natong i-substitute back. So mag-substitute, i-divide, then nakuha din nato ang iyang efficiency, which is the 0.408 or the 40.8%. So more atong efficiency and atong work done. So next katong C. So atong C, tara i-state dia sa babaw utro. And ato ading formula is QH minus QX, which is the 2.5 times 10 to the power of 14 joules and 2.5 times 10 to the power of 6. So 10 to the power of 6 muna siya katong given ganina sa problem. Ang QH na to muna katong sa nasa state gid sa problem. So atong i-substitute na pod, i-divide, and pagkuha na to is 1 times 10 to the power of 8 kilogram. Then assuming that the coal is a pure and that all the coal goes toward producing carbon dioxide. The carbon dioxide produced per day. So katong ang problem na kung pila daw ma-emit per day nga carbon dioxide. So atong isolve. Atong gamitan natong 1 times 10 to the power of 8 nga coal times sa 44 kilogram atong carbon dioxide nato, di ba? 44 kilogram to siya, and the 12 kilogram dayon ni divide. So atong makuha is 3.7 times 10 to the power of 8 of CO2. So this is 370,000 metric tons of CO2 produced every day. So dako jud siya og kuan emission. So mo nang dili kayo gina kuan gyud ang kaning mga coal power nga factory gina promote, grabe man gud siya mo produce og CO2. So that's all everyone, that's the sample. So we are the group of heat engine, the group 2. Maxon J. Baloca, Joanna Cristel Bilingon, Beverly Tavios, and we'll send the quiz, and please do enjoy answering. Thank you.